Module 6, Challenge Activity 6.2.1. Suppose the mean height in inches of all ninth grade students at one high school is estimated. The population standard deviation is 5 inches. I want to pause right there. The population standard deviation is 5 inches. That means that we can use the Z numbers. We use the standard normal because we know the population standard deviation. We don't use the T stat. We use the Z stat. The heights of 8 randomly selected students are 63, 61, 65, 72, 66, 61, 73, and 66. So we need to find the sample mean, X bar, margin of error at the 99% confidence level, and the interval. So I have already handily typed all this information in over here. So the first thing we need to do is find that sample mean. So we're gonna go ahead and say this is the mean equals average, select those 8 observations. So we can go ahead and put in, what is that, 65.875, or we can round it up, 65.8888, yep. Okay, margin of error. So the margin of error we can actually use using the confidence function in Excel. But first we need to, what makes it a little easier is if you go ahead and put in the population standard deviation, and we were given that as 5 inches, and then the number of observations n equal, you can either just type in 8 or you can just say count. And the reason this is handy is if you have a bigger data set, but that count just tells you how many cells are populated. And then we're going to say the margin of error equals, and we're going to use confidence. And remember, we're using the norm because we know the population standard deviation. So our alpha, when our margin of error is 99%, our alpha is 0.01. Remember, it's like if we were to divide this by 100, we would get 0.99. And so then we say 1 minus 0.99. That gives us that 0.01. Our standard deviation is that population standard deviation, and our size is the number of observations. So we're going to close that parenthesis, click OK. That gives us 4.55. So we're going to put that here for our margin of error. And remember, for our 99% confidence interval, we subtract 4.55 from the sample mean, and then we add 4.55 from the mean. So we can, I just say lower bound is equal to our sample mean minus our margin of error, and our upper bound is our sample mean plus our margin of error. Click OK. So we have, let's move this over so we can see it at the same time. Our lower bound is going to be 61.32, and our upper bound is going to be 70.43. Let's check. Nice little green check mark. We have a nice little explanation here for everything too, but the idea is that we already went through all that, so you don't need to cover it again. Let's go on to the next part. All right, the additional growth of plants in 1 week are recorded for 6 plants with a sample standard deviation of 2 inches and the sample mean of 10 inches. So in this case, we're not given the data set, we're given the summary statistics. So we need to find T star at the 0.1 significance level. Now I'm going to scroll all the way. Now, the first thing to remember is our degrees of freedom is n minus 1. In this case, n is 6 because we have 6 plants, so n minus 1 is 5. So we're going to scroll all the way back up here to find this nice little table that gave us with the nice degrees of freedom of 5, 10, 15, and 24, which are common enough numbers. And our alpha is 0.1. So we know that our T star is 2.015, okay? Our T stat right there. I'm going to scroll all the way back down and put in that 2.015. Now our margin of error. So to do this, we're going to go back to Excel, and we're going to first put in our sample mean. We are given it as 10 inches. Our sample standard deviation is given as 2. Our sample size is 6, so we're going to say margin of error is equal to confidence. And we're using the T distribution this time. We do not know the population standard deviation. We're using sample standard deviation. So our alpha is 0.1. Our standard deviation is that 2. Again, you could just type these numbers in. I like doing this because I think it's good practice. because when you're manipulating bigger data sets or you want to save this work for later, it's handy to go ahead and put it in like this. And then the size is that B3, that's 6. So that gives us a margin of error of 1 point, and that's for 3 decimals, so 1.645. 1.645. And then we're going to say our lower bound is equal to our mean minus that, and our upper bound is equal to our mean plus our margin of error. Oops, I just did that by accident. So sorry, our upper is equal to sample mean plus the margin of error. All right, so let's put these numbers in. We have 8.35, about 5 when it rounds, 355, and our upper is 11.645. Let's check that. Nice little green check mark. All right, that is challenge activity 6.2.1. Let me know if you have any questions about that or anything else.